Welcome to the first virtual lesson of a series of online lessons developed by the Academic Subcommittee of the Council 2021-2022 of the College of Community Physicians of Sri Lanka, to promote the continuing professional development of its members. This session focuses on selecting an appropriate statistical test. Selection of appropriate statistical test is a very important step in the analysis of research data. There are different specific objectives a researcher wants to achieve in a given study. This lesson guides the researchers on choosing the correct statistical tests in achieving the specific objectives that require comparing two or more groups of study units in relation to a particular result to verify whether the apparent differences are statistically significant. Determining whether the results of two variables of a particular study group are associated with each other, and to verify whether the association is statistically significant. A wrong selection of the statistical method not only creates serious issues during the interpretation of the findings, but also leads to erroneous conclusions. As we are all aware, there are a number of statistical software capable of performing numerous statistical tests. However, statistical software does not have the ability to make decisions on the correct statistical test to be used in a given situation. That is why knowledge on choosing the correct statistical test is essential for the researcher. In this session, we aim to present an easy and user-friendly method to choose the correct statistical test. The method presented here is applicable to both descriptive and experimental study designs. When should a researcher choose the statistical test to be used? Is it at the stage of analysis? Ideally, presentation of results and statistical tests to be performed to achieve each of the specific objectives should be decided upon at the stage of planning of the research. Based on the specific objectives of the research, the researcher may use different statistical tests to present the results of the given research. The method presented here is a simple checklist of 4 questions and a series of flow charts, which enables you to reach the test that is relevant to the situation in which you need to apply statistics. Following is the checklist of 4 questions. Question 1. What scales of measurements have been used? Question 2. Which hypothesis has been tested? Question 3. If a hypothesis of difference has been tested, are the samples independent or dependent? Question 4. How many sets of measurements are involved? The first question that needs to be considered is what scales of measurements have been used in a given study. The basis on which the numerical values are assigned to different observations determine the scale of measurement being used. The traditional classification of scales of measurement describes 3 types, namely 1. Nominal scale, 2. Ordinal scale, and 3. Interval scale. Nominal scale. If the researcher simply uses numbers to label categories, where the categories do not represent any order, then the scale of measurement used is the nominal scale. For example, in a descriptive study, where a researcher plans to compare the differences of results between males and females when tabulating the results, the researcher may assign numbers 1 for males and 2 for females. By doing this, the researcher is not indicating that females are more or less in relation to sex, indicating that categories do not represent any order. Or else a researcher may want to check whether the eye color is black or other of a study population is associated with the presence of a disease condition, and here, he or she may assign numbers 1 and 2 for both variables, in other words, for the different eye colors and for having or not having the disease. By doing this, the researcher is not indicating that either the eye color or the presence and absence of the disease are more or less in relation to each other, indicating that categories do not represent any order. If we take another example from an experimental study, where the type of the side effects experienced by the experimental group and the control group are to be compared, the researcher may use the nominal scale and tabulate the results of different side effects. Though the researcher may also assign consecutive numbers for different side effects, it does not indicate that one side effect is higher or lower than the other. Nominal scale is considered the lowest form of scale of measurement, as it does not provide any information on the relationship between the categories. Results of research data measured in nominal scale would be presented as frequency distributions for the groups being compared. Ordinal scale. If the researcher uses numbers to label categories in which an order can be identified, then the scale of measurement used is the ordinal scale. In other words, here the relationship between categories in terms of greater than or lesser than status can be identified. In descriptive studies, where the different groups of study units are to be compared based on their level of satisfaction to a health service, the researcher may tabulate the results using categories of highly satisfied, somewhat satisfied, and dissatisfied. This categorization also provides information on the relationship between them. Or in an instance where the researcher is checking whether the number of pets at the home of a study population is associated with the episodes of asthma over the last 6 months, the researcher may tabulate the results as 1 for no pets, 2 for 1 to 2 pets, 3 for more than 3 pets. And also the numbers of episodes of asthma as 1 as none, 2 as 1 or 3 episodes, and 3 as more than 3 episodes. We can see that this categorization also provides information on the relationship between them. In experimental studies, a researcher may use ordinal scale to categorize study units in both experimental and control groups, based on the type of response that they will experience following administering a drug using the categories such as very good response, and poor response. Again, this categorization provides information on the relationship between the categories. It indicates that very good response would be or is better than good response, and good response is better than poor response. However, it should be noted that ordinal scale does not numerically quantify how much greater very good response is when compared to a good response. Results of research data measured in ordinal scale would be presented as frequency distributions for the groups being compared. Interval scale. When the researcher assigns the numbers to observations, and if the number represents the actual magnitude of it, this scale of measurement is called interval scale. Other features of the interval scale are that the difference, or the interval of two such numbers that have been assigned are meaningful, and theoretically, the distances between successive points in the interval scale are equal. In a descriptive study, a researcher may plan to compare heights of different study groups and may assign them the values in the interval scale using the unit centimeter. A person who is assigned the number 150 centimeters is taller than the person assigned the number 140 centimeters, and the difference of height between these two persons is 10 centimeters. Or else, an instance where the researcher plans to determine whether the weight of a study population is associated with their heights can be taken as an example of a situation where data in interval scale is used when determining associations. In experimental studies where the researcher compares the response to a drug between experimental and control groups, he or she may use interval scale to record the results. An example would be the improvement of hemoglobin level in an experiment of evaluating the effectiveness of a hematonic. In this instance, a person who has an improvement of 3 grams per deciliter has responded to the drug better than a person who had an improvement of 1 gram per deciliter, and that the difference of improvement is 2 grams per deciliter. It is also true that the difference between two persons of 2 grams per deciliter improvement and 3 grams per deciliter improvement is equal to the difference between two persons of 4 grams per deciliter improvement and 5 grams per deciliter improvement. When comparing the results of research data measured in interval scale to determine whether the differences among the groups are statistically significant, or whether there is a statistically significant association, they are presented using measures of central tendency such as mean, mode, median, and dispersions such as standard deviation and standard error. At this stage, when we have determined the type of scale that has been used to measure the results that have to be statistically tested, we can make some decisions regarding the collective group of statistical tests that we may have to use. With this regard, The statistical tests, which could be used, are summarized in this table. Question 2. What is the comparison to be made? Which hypothesis has been tested? The second question to answer is about the type of comparison to be made and the hypotheses to be tested. There are only two types of hypotheses that can be statistically tested in research. They are either a hypothesis of difference or a hypothesis of association. Hypothesis of difference states that the difference that is shown in the results of the groups is also different in the larger population groups from which the samples came. Testing of hypothesis of difference will always involve a measurement of a single outcome made on two or more groups. Examples of research questions where hypothesis of difference is tested were given when we described the scales of measurements. The hypothesis of association states that the relationship of the two or more sets of outcome that we see in the results obtained from the sample is also present in the larger populations from which the sample came. Testing of hypothesis of association involves measurements of two or more sets of outcome within a single sample. Examples of research questions where hypothesis of association is tested were given when we described the scales of measurements. Question 3. If a hypothesis of difference has been tested, are the samples independent or dependent? Third question is applicable only if the hypothesis of difference is being tested. As mentioned previously, testing for hypothesis of association involves measurements of two or more sets of outcomes within a single sample. Hence, this checklist question becomes irrelevant. In the instances where the hypothesis of difference is being tested, if the selection of one of the samples is in any way influenced by the selection of the other samples, we call them dependently selected. An example of dependent sample selection in either descriptive or experimental studies will be when matching criteria have been used in selecting the groups to be tested. An experimental study in which the same subject acts as his or her own control is another example of an instance in which samples are dependent on each other. Following checking on selection of sample, if the researcher is convinced that selection of one sample has not, in any way, influenced the selection of the other sample, he or she should consider them as independent samples. In descriptive studies or in experimental studies, if the samples are selected using random sampling techniques, the samples are independent. Question 4. How many sets of measurements are involved? The last question to answer is the easiest. It is about the number of sets of groups or outcome measures that are involved in the analysis. The question inquires whether the hypothesis of difference is testing only two groups or whether it is more than two. For example, if in a descriptive study, the research question to be answered by statistical testing is whether there is a difference in the prevalence of childhood malnutrition in urban and rural sectors, it indicates that two groups are being tested. If an experimental study involves three groups, such as one experimental group and two control groups, or two experimental groups and one control group, and if the research question was whether the response to the drug is different among the three groups, it indicates that more than two groups are being tested. Similarly, if in a descriptive study, the hypothesis of association is being tested and the question to be answered by statistical testing is whether there is a relationship between stunting and wasting of preschool children in rural sector, it indicates that two sets of outcomes are being tested. If the research question is to test whether there is a relationship between stunting, wasting and head circumference of preschool children in rural sector, it indicates that more than two outcomes are being tested. Now that we have discussed all four questions, let us quickly go through them again. Question 1. What scales of measurements have been used? Question 2. Which hypothesis has been tested? Question 3. If a hypothesis of difference has been tested, are the samples independent or dependent? Question 4. How many sets of measurements are involved? First, we will have a look at the flow chart on statistical tests to be used for comparison of data measured in the nominal scale. As shown here, in case of hypothesis of difference, and if the samples are independently selected, chi-square test could be used, whereas if the samples are dependent, then Mach-Nemar chi-square test could be used. On the other hand, in case of hypothesis of association, coefficient of contingency could be used. Now, let's have a look at the flow chart on statistical tests to be used for data measured in the ordinal scale. When dealing with ordinal data of a study assessing the hypothesis of difference of independent samples, Mann-Whitney U test could be used for 2 measures, while Kruskal-Wallis test could be used for more than 2 measures. Further, if the samples are dependent, we could use Wilcoxon t-test when there are 2 measures. And Friedman-ANOVA by ranks could be used for more than 2 measures. When dealing with ordinal data of a study assessing the hypothesis of association, Spearman-R could be used. However, in case of interval scale, we need to answer a further question, which inquires whether or not the measure is normally distributed in the population. Most of the time, we come across measurements made in interval scale, and we can use the given flow chart to decide on statistical tests to be used in such instances. As shown here, in case of hypothesis of difference, and if the samples are independently selected, independent t-test could be used for 2 measures. However, if there are more than 2 measures, we could use one-way ANOVA. In instances where the samples are dependent, paired t-test could be used for 2 measures, while repeated measures ANOVA could be used for more than 2 measures. On the other hand, in case of hypothesis of association, Pearson-R or multiple R could be used based on the number of measures. As we have mentioned at the beginning, selection of appropriate statistical test is a very important step in the analysis of research data. In this lesson, we discussed how to select an appropriate statistical test, simply by responding to a checklist of 4 questions and to following a selected flow chart according to the scale of measurement. We hope you have found this presentation useful and hope you would join us for further videos on similar topics.